Okay, so let's get started. We're going to be taking a look at our VTC scheduling found within our Gen 3 Coyote engines. Now, this tutorial is going to be an overview and the basics of how our VCT scheduling works within the engine control module. The VTC schedule is very important to understand to get the best operation out of your engine, but also how it translates itself into a lot of the other tables and the programming logic within the Ford control module. So we have things like our torque tables, spark timing tables. We also have speed density tables. They're all driven off of what's known as mapped points, which is called out in our VTC scheduling. So we definitely want to understand this. We're going to be digging into this pretty heavily in the next few tutorials. Again, this is an overview of how the system operates and works. So the goal here at the end of the tutorial is understanding the different modes that you operate in with the VTC scheduling, as well as how it translates throughout the rest of the programming logic in our Gen 3 engine control modules. So let's jump in here. Let's open up a stock equivalent file for this tutorial so we can take a look at a few things and start to understand how this all works. First thing I want to do is move up to the top of the software here. Let's go up into File, Open. Let's go in here to our desktop and let's move into our HPT Gen 3 Coyote Course folder. And then in here, we're going to move into our sample calibration file subfolder. Now we can grab any of our stock files. We can take a look in our list here. There's some Whipple and Roush files. We want to avoid opening those up right now simply because the VTC scheduling is going to be customized and unique, and it's not the way that Ford intended the programming to be used. Now you can go in and do custom VTC scheduling, and I'm going to show you how to do that in another tutorial coming up here. But for right now, we want to stick to a stock Ford file so we don't make this any more confusing than it has to be. There's a lot going on with this. The Whipple and the Roush handle things differently. That's because they have the supercharger installed and they've removed the intake manifold runner control, which simplifies the system, but it's always, in my opinion, better to look at how Ford intended the logic to be used so you understand how you could modify that in the future. So that's what Whipple and Roush have done. They've modified it and changed some things. But let's look at the way that Ford has intended this to be used. So what we're going to do is let's open up a 2019 Mustang GT stock file, and we can take a look at things from there. So now that the file is open, I'm going to go up here into Engine, and let's go over here from General into Airflow, and then in Airflow, we're going to skip all the way across here over into our Variable Camshaft tab. Now in here, we're going to find a lot of different tables and parameters. It can look super overwhelming, and it kind of is a little bit overwhelming at first, but we'll make sense of this hopefully by the end of the tutorial, how this all fits together. We're only going to be using probably about a third of the settings or tables in here. So a lot of it you're not going to touch, but we do need to understand how the system works. So let's jump in here and let's start to break this down. So the very first thing I want to talk about here is mapped points. We can see right here, map points is an area that we can start to edit and work with and take a look at. So looking at our map point configuration, let's look at our list here. We're going to find that we have 26 total map points in a Gen 3 control module that we could potentially enable and work with. We will find that the map point OP or optimal power is turned off. So this list right here, everything has a 1 except optimal power. That is disabled, and that is fine. We don't need to enable optimal power. There's no advantage in doing so. Looking at this, map point 0 to 13 is used when the charge motion valve assembly or intake manifold runner control is closed. And then once the intake manifold runner control charge motion valve assembly opens, we'll be using and referencing map points 14 through 26. Now, if you've deleted the intake manifold runner control, you'll be referencing map point 14 through 26. We'll talk about how to do the delete properly and how to program our VTC scheduling around that in another tutorial. But for right now, understand that's the point or the purpose of all of the map points. 0 to 13, runner control closed. 14 to 26, runner control open. So it's pretty simple. So the map points, let's close out this window here. We know that there's 26 in total. Let's skip over our snap to point and snap to line. We'll cover those in another tutorial. What we're going to find is we want to open up our intake valve opening and exhaust valve closing windows to understand how that translates, how the mapped points translate to where we want the variable camshaft movement to go to during our engine's operation. So let's open up these two windows. So intake manifold or intake valve opening and exhaust valve closing. Let's just shift this window over here and just minimize this a little bit so we can access everything on our screen. So let's go ahead and just overlay these two. So we have intake valve opening, exhaust valve closing. In our list here, we see that there's map points 0 to 26. And then in here, if we look at specifically the intake valve opening, we're going to find that map point 0 here starts at 0, and then it goes to positive values, and it goes to a negative value. And they kind of change throughout the list here. So we can see they're varying a whole bunch. Now we also look at our exhaust valve closing, and we can see it goes here from 0. There's no negative values in here. It just goes into positive values. We can see that goes to 50 degrees as a maximum. And depending on what the map point here is called out, we have these different cam pairings, or where we want the variable cam shafts to rotate to between the intake and exhaust cams. So let's break this down. This is a little bit confusing. So the first thing I want to talk about is what the values actually represent here when we call out a mapped point. And the map points are called out from the VTC schedule. We'll talk about the scheduling here, but we're trying to figure out what these numbers actually mean, because this can be a little bit confusing. So anytime we see in our intake valve opening a value of 0, that's going to be referencing here, if we take a look at our intake camshaft, our intake valve closing and intake valve opening, the values that we find right here, this is called out in the...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.